Okay. So what are we actually going to discuss today? So first we'll discuss why cloud. As I said, this is actually flagging the target that we want to achieve. And the first question to ask is why actually we want to gather, but what benefits will it give us to the organization, why this is the direction we're heading. Second, to better understand what we mean by when we're saying clouds, we'll discuss very briefly the different types of clouds that are out there. Then we'll discuss what it means to be cloud native and why do we actually need that. We'll see a case study of a company who's made that transition and the things they needed to do along the way to get to that point and to understand the magnitude and how long it took them together. And then we'll have a Q&A in a slightly different format. We'll see it when we get there. Okay. So the first question is why cloud? And I must say that like all very important business questions, there's only one single answer. Of course. Okay, so and when we're saying money, it actually comes from very different directions. We'll see it in the case study in more detail, but it's not only to save money, right? Because all of us can say from our sleep that yes, managing our own data center in the classic way costs a lot of money. We know we need to pay a lot for electricity, not only for the servers, but also for the air conditioning, right, and stuff like that. Bandwidth is very expensive. Servers are getting old. They need to be replaced every few years. To keep up and keep them alive. We know that a lot of the servers will be underutilized because in our data center that is static, it's very hard to make sure that all the servers are actually working and, we don't have a lot of reserve power that we'll need for peaks and so on. So it's not only that we're saving a lot of money, later on we'll see how actually transforming to the cloud can gain us new revenue, which actually means that we can make money by going to the cloud, which is very tempting. Okay, so now that we understand the bottom line, that's the only motivation you need to remember. Let's move to the different types of clouds that are out there. So the first type we have is public cloud. I think this is the most famous type. We know there are a lot of vendors that provide public cloud capabilities. Actually, I went to a site listing all of them by price, and I was surprised to see that there are like 50, I think. Some of them I've never heard of. There are a lot of niche cloud providers out there, but the most famous ones are obviously Amazon. We have Azure by Microsoft. Google has actually two types of clouds, one for VMs, one for containers. Rackspace is also a famous one. DigitalOcean we are using, so we are aware of that, and many, many more. Okay. The point is that all the servers and actually the data center that we're leveraging is not located in our site. It's located somewhere, not always you know where. In Amazon you can choose, right, the region that you want to place your application on. Someone else is managing it, taking care for it, everything. We consume it as a service, right? And I'm talking about the infrastructure layer here. So we're consuming the machines as a service. Okay, that's the obvious part. Private cloud. Private cloud, it's kind of a different thing. We'll touch it later on. Not everyone that has its own VMs in his data center can call it a private cloud. We'll see why. So actually, let's assume that this is really managed as a cloud. We'll later explain what it means. Everything is hosted in my data center. It can be for one of two reasons. Prominent one is security, right? There are organizations, maybe government, federal, healthcare, that have very strict policies. They cannot really put their application and mainly their data out there in the cloud. So they prefer to do it on their sites. And we know that it has its own limitations, right? Because they need to take care of a lot of things that the cloud provider would have done for them. And because of that, we don't have just public and private, but a lot of combinations, weird combinations have evolved along the years, which are the two following types, hybrid and virtual private. So each one of them tries to minimize the pain of having a private cloud in a bit different way. So hybrid actually means that it's like eating the cake and keeping it whole. I want a private cloud. There are a lot of things I need to run on my local site, but I still want to leverage the power of the public cloud for different reasons. So I'm having both. Okay, so I'm utilizing servers on my private cloud and on my public cloud. And I want to give you two extreme examples of why people are doing that. I'm sure there are a lot of, other examples in between those two extremes. So one can be for security reasons. As we said, I need to keep my data, maybe other things in my private cloud, but I understand that it's much more efficient to manage things in the public cloud. So I will have it mainly on the public cloud, and only for the data that I cannot keep there or for the calculation computation that I cannot do in the public, I'll do it on my private cloud. Another example is I want to manage everything on my private cloud because it's easier. Maybe I have a more legacy mindset. I'm not willing to make the shift and just put my IP out there. But I know that I have peaks of service, right? Maybe I'm an e-commerce provider, and I know that during the holidays I'll have a lot of traffic and I will not be able to accommodate it. So I have those machines in Amazon, right? It's not actually a machine. I have a subscription for Amazon. And when there's too much load in my data center and I cannot take it anymore, I just scale out to the public cloud, okay? And then when the peaks goes down, I'm back into being solely managed in my private cloud. One point, regardless of this discussion, that's worth noticing here is that this use case is very problematic from management point of view, management of the infrastructure and application. The next invention is virtual private. Virtual private cloud, also known as VPC. This is an invention that does the opposite. It says, okay, I want the power of privacy, right? But I understand that managing it in the public cloud is the most efficient way for me, money-wise, obviously. And I want to have like a virtual private cloud, but not hosted on my site, but on, let's say, Amazon. Amazon Web Services provide this. Also, Google provide that. And as you know, ES from HP, that is now CSC, also provided that capability of VPC. What it actually means is that the vendor, the public cloud vendor, isolates from network perspective, storage perspective, okay, host perspective, and they do obviously different levels of isolations, but promise me that everything I manage is totally segregated from any other customer who's running on that public cloud. Obviously, it costs a lot more, and it limits my ability to scale out, right, on the fly, because maybe the vendor can't support it that fast to do all this network isolation to encompass more and more and more servers as I grow. So it might be very challenging. And but for many companies, this is currently the only solution they can adopt, and we know there is a big market for that. So let's move on. Just one note, what we've discussed so far is in the infrastructure level, okay? As you probably know, there are different service levels in the cloud. You can provide infrastructure, you can provide platform, you can provide software, right? Software as a service. I'm not discussing this entirely in this presentation because from the cloud native application point of view, it doesn't really matter how much infrastructure it got, right? Like the developer may be, struggling less if he's writing on a PaaS and not on infrastructure, right? But he needs to face the same challenges and comply with the same things. Yes, different tools exist to make his life easier, but this is what we'll discuss in the next session. So I'm disregarding completely the whole different service levels that we have in the cloud. Okay. Okay, so we know why we want to move to the cloud, right? The organization wants to save tons of money. We know we have existing applications that were not written for the cloud, right, in mind. I will not call them legacy because maybe we shouldn't install them that much, but they are not really fit for the cloud, right? They are not cloud native. So one question would be, why bother, right? Maybe I will just take my application, put it in the cloud, right? Run it on Amazon, and it will run, let's say, most of the time pretty well. Um, so the point is that up till now we discussed only the benefits of the cloud, and we made a lot of promises, right? You'll save a lot of money, you'll be able to make more money, but we didn't mention the real thing that actually the application will need to face when it comes to the cloud. And running on the cloud is like running in a jungle, right? It's not like that safe environment that the application was used to up until now. It's like it has to face a lot of things. We'll list them in a minute. And in order to really fit in and gain that revenue and efficiency and saving all that money, we need to make sure it does fit in. Okay? So we understand that if we want to leverage cloud, we need to make our applications cloud native. To better understand what cloud native is, there is a great analogy, really good one, that a very smart guy called Randy Bias has coined back in 2012. He published on SlideShare a really great deck that I shamelessly stole a lot from in the following section. So if you want, you can take a look on that. And pets versus cattle actually means the following. When we're talking about the servers that we have that our application will run on, we can imagine different types of animals and find the equivalency. So let's imagine pets, okay? I'm sure most of you have pets in your home or want to have pets in your home. And we know that pets get a very emotional relationship, right? We give them names, right? They are unique. And they're lovingly hand-raised, right? You cannot go away for a vacation for a month or two and say, yeah, they'll manage. Someone will come and feed them and it will be okay. When they get ill, you nurse them back to health. Spend lots and lots of money. Right? And when they die, and we know that eventually they die, right? Replacement is not easy, okay? It's very, very hard. So run the analogy in your head and think about production servers that we know our customers have, right? They have names, right? They are unique. They are hand-raised for sure, right? When they get ill, how much the IT spends and how much we used to spend to nurse our second machines back to health whenever they crashed, and they crashed. And the replacement was not easy, right? Because we put all of our resources and faith in those machines. How can you take it away and just expect me to try and use a new one? On the other hand, if you go to a farmer in Texas that raises thousands and thousands of cattle heads, he has a totally different experience, right? So his cattle, I don't know even how to say it in singular because you don't say it in singular, right? You don't manage them one by one. They don't have names. They have numbers, right? And they're even clipped to their ears because you can't really identify who's who. So you need to see it in a way. They look almost the same, obviously treated the same, right? All get the same food, same medication, same care and treatment. If you need more, you pick a phone, click something on a website. I don't know how it works. You get more, right? You don't lose a minute's sleep over that. And when they get sick, they are being replaced. A very important point to notice here, we're not talking about something hypothetical. It's not when and if they will get sick. They do get sick, right? When you have thousands of cows in your herd, every day more than one cow will be sick and will need to be replaced. It's the day-to-day reality you're facing, and you're no longer coming home from the field and telling your family, oh no, that cow is sick. I have a problem with 2 sick cows. Every day you have 2, 4, 5, 10, I don't know how many sick cows. You just handle it. You have a process for that. You really don't sweat over it. Okay. Now, a very important point. Someone who will just see these slides will come and say, yes, I have a cloud. My data center resembles the cattle analogy. Why? Because everything is virtualized. I have only VMs. So obviously it's kind of funny, right? It's like my kids will persuade me to buy a cow, a single cow, or maybe two, and we'll raise them in our backyard, and we'll say, yeah, we have a cattle. We treat it as cattle, right? No, we'll still call them by names. We'll still love them individually. We'll hand feed them. When they'll get sick, we'll call the vet, and we'll spend a lot of money for special food for that one and for that one because, right, we treat them as pets. So it's not enough that you have VMs. You need to treat them as cattle. Okay. Hope we got the point. Okay. So now let's try to be a bit more interactive. I hope the latency will allow us. Again, we're talking about the servers, okay, not the applications yet. We didn't get to that point. We're just saying what ecosystem our applications will need to manage when they will be deployed in the cloud and having running on cattle instead of running on pets. And we'll give a concept of how it's done in enterprise computing, and you will tell me how it should be done when we're managing it as cloud. Okay. So again, servers, remember, they are GUI driven, right? If the sysadmin has a problem with some machine, he opens the console to that machine and starts, clicking around in the machine and taking care of it. In the cattle world, what do we need? What? I'll help you. API. Okay? It's not the sysadmin who's going to nurse that back to health. It's going to be some tool, right, that will try to call some APIs, maybe using OO. And if it won't work, it will just be thrown away. Okay, ticket-based, right? You open a ticket. I have a problem with my machine. Someone will actually manage it, right? It's not how it works in a cattle. You don't go one by one and seeing if everyone feels okay. You have self-service, right? I don't think it applies to cows in this manner, but if you have a problem with a server, you need to be able to handle it, right? Because the sysadmin will not take care of each and every machine that he has in his data center. Okay. Pets are handcrafted, right? It's more the analogy here comes from the traditional making of cars, where everything was handcrafted and assembled manually, right? Versus there's a nice picture there with robotic arms that give you a Mercedes in 5 minutes. So these are handcrafted, and here it's automated, right? No one will actually attend to that machine manually. Okay, it's not working that well. Reserved, right? If I know that I need to test a cluster of OO, I will make sure in the old world to get 5 machines, tell everyone don't touch them, I need them for my tests. I will maybe change the password so no one will be able to get it. Obviously, it cannot run that way in the cloud. In the cloud, it's on demand, right? My test will spin off those 5 machines and they will die once my test is completed. Scaling up versus scaling out. We'll have a slide for that in a minute, and we'll explain in more details. Okay, this is a very important point. In the enterprise computing, we had smart hardware, right? We need strong machines, reliable machines. You get smart applications, you can run on commodity hardware, right? You don't rely on the bare metal for the success of your application, not in the cloud. Pets, again, proprietary, right? A lot of black boxes, right? I bought this from a vendor. I don't really know how to troubleshoot it. I don't know what to do when it falls down, but it's okay. I'll open a call. They'll get back to me in 24 hours. I pay for platinum service, right? And then we'll resolve it. Doesn't work in the cloud. In the cloud, it's open source. And to manage such data centers and to write applications for those data centers, in enterprise computing there was the traditional dev, but in cattle they need to be DevOps, right? Because they need to take things end to end. There's no one who will handcrafting, take care of their servers for them, right? They need to be able to handle it on their own. Okay, so let's explain some of the concepts that we've mentioned. Not all of them, very few of them. One is actually the scale out versus scale up. So what we're used to in the traditional way of running our applications, we know that if we need more power, we press turbo, right? We know it in our benchmarks. We don't run on a giga or 2 gigas of memory. We run on 4 gigas of memory, or 8, or if required, one day we will run on 16. This is not the way you do things in the cloud, right? Because in the cloud, you don't have time to inflate and inflate and inflate a single node of your application. It needs to be very fast. So the fastest way is to scale out. That's for one. And second thing is that you're running on commodity hardware. Who knows if that commodity hardware can really handle a Java process with 16 giga of memory, right? Who says? So you have a lot of cheap boxes, use them, right? So scale out. So this is what we call in the more professional way, vertical scaling and horizontal scaling, right? Also, if you notice here, again, a slide from Randy, he mentions that when you scale up, usually start with a pair, right? Because we're used to high availability, and we say, yeah, to get high availability, we need 2. But it's nonsense, right? Because even 2 can fail. So you can start with 1, and just, if that one fails, scale, right? Spin off another one, and another one, and another one. So you should have 2 only if you really need 2, right? We said no reserving, it's on demand. Okay, and now just to emphasize, I found a really nice picture I had to share with you. So this is the power of horizontal scaling, okay? And just imagine it can get bigger and bigger and bigger. Okay, another important point for cloud native applications is that, again, not my phrasing, hardware fails, software fails, and people fail, right? So you cannot rely on any of them. So just make sure that your software checks regularly that everything is okay and it can fix itself when there is a failure. Okay, either your application or tools in your deployment, right? Doesn't necessarily need to be your application, but your deployment as a whole need to know that this will happen and it has to take care of it on its own. It can't wait for anyone to manually fix the problem. Okay, just to mention in a word before we move to the next subject, other things are different as well in the cloud world, right? So we said you're running on commodity hardware. You cannot rely on the power of the hardware you're running on, amount of memory, strength of CPU, whatever, reliability of the hardware, right? It can fail. It's just like the machine you have at home. It's not a fancy server or anything like that. Storage. Again, not allocated to you, not owned by you, shared with every other application, probably unless you have some privacy like a virtual private in the cloud. Attachment of storage is different. I will not get into that because I'm not a storage expert, but there are a lot of information out there about how storage is managed in the cloud, and it's totally different. SDN is an important point. I'll just mention it in a sentence. Software-defined networks. Actually, the whole point that enables us to have a cloud that is so elastic and responds and doesn't need human intervention is because things are not physical anymore. If you remember in the old days, remember it was before we were born, when someone made a phone call, someone needed to take the plug and put it in the switch to connect the calls, right? And today you have digital switches, thank you, that do that for you, right? Because it's software defined, right? The connections between the network points are software defined and thus can be automated. So again, if network was still, hubs and switches that needs to be plugged in and clicked on and stuff like that, we wouldn't have clouds. So everything is software defined, especially the network. And network architecture is different. So a case study, okay? So I think up till now it sounds a bit like science fiction, right? We know There's a whole new tempting world of the cloud out there. We need to make a lot of changes to be native at that world. Can it really be done? So Netflix example is a good one, not only because it's a very famous one and a successful one, which is always nice, but also because their business criticality, it's kind of hard to really grasp it. But if you think about, let's say, Amazon, like the shop Amazon, okay, you can say, yeah, every business disruption has a huge impact because they lose a lot of sales, right? If I'm about to buy a book and the site crashes, I will obviously go to the book depository to buy the book, right? And they lost me. In Netflix, it's even worse because they're doing live streaming the whole time. This is how people in America watch TV. And if there's a disruption in the service, people will leave them in the masses, right? Like cancel the subscription. It's not like this book I bought from another vendor because I had a temporary problem with our service. So Netflix is like the extreme example of business risk in doing that, which makes it even more absurd when you learn how they manage their data center, okay? But it does pay off, as you will see. So again, I took it from a blog written by Yuri Israelevsky, who is their VP Cloud in Netflix. And he describes the transition that they've started in 2008 and was completed in 2015. So quick math, 7 years. It took them to migrate everything. He points a lot of important things. I hate slides with so much text, but it was like every word in gold here, so I will try to just point to the important things. So how it actually began, in 2008, they had a problem with their database. They had a relational database, right, like everyone used to in that time. And they lost their DVD streaming service for 3 days. Okay, imagine the business impact, 3 days. So it was like a total disaster from Netflix point of view. And they understood that they need to stop vertically scaling things up and make things stronger and stronger, because it just means that they become more and more single point of failures in the system. And they need to start using highly reliable, we'll get to that, horizontally scalable and distributed systems in the cloud. Okay, so horizontal scalable we get, right? We said a lot of commodity hardware, you can spread out as much as you want. Distributed systems, yes, one in Jamaica, one in, New York, one in the East, whatever. Yeah, it's distributed. You get a lot of redundancy and risk management. Highly reliable sounds a bit weird, right? I've been trying to convince you in the last minute that the cloud is a cruel world. Nothing is certain, everything might fail, everything will fail, right? How come he's saying that running on the cloud is the highly reliable solution? So quoting again from his blog, he says that failures are unavoidable, right, in every large scale. As we said, cows will get sick and die, right, when you have more than 1,000 cows, even in the cloud. But the cloud allows one to build highly reliable services out of fundamentally unreliable, but redundant components, which actually means that, yes, cows get sick, but I have so many cows that if one gets sick, I'll just use another one, right? If that server crashes, no problem, I'll move to run on another server. And this is actually what gives me reliability, the availability of all these resources that can help me run my application. Okay, so this is why Netflix conceived the cloud as a reliable place to run their application on. And now comes the really important question of why did it take them 7 years? Yeah, Netflix has a lot of software, but אפשר לחשוב, as we say in Hebrew, how much software do they have? How much time does it take to take it, make some tweaks and changes, and just put it on Amazon? Not such a big deal. So Yuri, being a very smart guy, says that, yeah, we could have taken all the applications we had from our data center and just take them and put them on Amazon Web Services, right? They would probably work at some level. But the point is, it doesn't need to do anything. Okay. But the point is that you're actually porting the problems that you used to have into the new environment. And as we know, the cloud is not a friendly environment. So if you have single point of failures in your system and you're porting it to the cloud, it will crash more often. So you'll just get more and more and more problems. So this is not the way to do it. The way to do it is actually rewrite your applications as cloud native ones, right, to make them behave natively in the new world and cope much better with the challenges that they're facing in the cloud. So now we get to the real extreme, okay, because we said that the cloud is a very cruel place, right? We said it's like a jungle. And there are a lot of surprises and unexpected failures, and so more to say, expected failures, just you don't know where they will be coming from. What Netflix did was really amazing. They started by saying, okay, we know that the cloud will fail, right? Because this is the nature of the cloud. But we know that we don't want to be surprised by failures at the beginning while we're ramping up on running on clouds. It's much nicer to simulate failures and see how our systems respond to that rather than waking up at 2 a.m. just because the system had failed and we need to take care of it. So what they've done, and it's not testing, okay? They didn't do it on a testing environment. They did it on their production environment. They've done it on AWS. They created what they call Chaos Monkey because they said, let's imagine we take a real monkey and unleash it into our data center. It will press buttons, right, shutting down systems we don't know which. It will chew the network cables because they're colorful and seem very tempting. And we need to make sure that while our customers are still consuming our services, right, video is still being streamed to our customers, our system can handle that chaos that this monkey is creating. So they've coded this Chaos Monkey, and they've unleashed it into their AWS. And they had a special team of people, monitoring and seeing what fails and how the application responds. Obviously, at the early days, didn't respond that well, and they needed to fix a lot of things in the resiliency of the system. But they got to the point where at weekends, at night, they didn't care if something went wrong, right? They didn't even have alerts to wake them up because the system can take care of things itself. They're not afraid of the chaos anymore. So they liked it so much that they built a whole army of such monkeys. And they started creating, this is just a short list, they have much more. They started creating more and more monkeys. So then they created the latency monkey, very similar to Shunra, if anyone knows it. It actually simulates latencies in the network because, the cloud is not only about the data center, but also about the network. So in AWS, there might be problems in routing the requests from site to site. So they have a monkey that does that. They have a streaming business, just to remind you, and they still cope with it. Conformity monkey is really important. They set really strict standards of how a service of Netflix should look like. They give an example. Every service must run as part of, how do they call it? A scale-up group, auto-scaling group, okay? And we know that if it's not part of an auto-scaling group, when there is a peak in the service, it will not be able to scale. So people will face a problem. So when they say such a service was not part of a auto-scale group, the conformity monkey simply kills it. Okay, and then the service will start properly attached to a scale-out group, auto-scaling group, and everything will be okay. It will be able to scale. Dr. Monkey is also a very funny example. It looks at sick machines, right, and kills them. And they were so excited by their Chaos Monkey that they say, why unleashing a monkey in my data center to cause local havoc when I can take down a whole AWS availability zone that's, think big. So a monkey cannot do that, it's too small. So they wrote the Chaos Gorilla. And the Chaos Gorilla takes down whole Amazon availability zones at once, and they see how they handle it. So next flood, hurricane, whatever, Netflix will run. Okay, you shouldn't be worried. All the tools they wrote is open source completely. You can see it in GitHub. It's their policy. They're saying it's not our business, right, to to manage data centers. Our business is to stream video. So we don't mind sharing it with the whole world. On the contrary, we want to have an open source community that will help us make these tools stronger and stronger. So you can see everything in GitHub. How they treated their application is very unique and specific to what their application is doing, okay? And B is part of their IP, so they're not sharing it. Okay. Obviously, the patterns they're using can be reusable, but not the actual solutions. And the patterns are like known things in the industry, right? You don't need, like they say, we moved from a relational database to NoSQL database. It's not something you need Netflix to tell you to do. It's kind of obvious. Okay, so I just wanted to summarize what actually cloud applications need to handle when they meet the cruel world of the cloud. So first is resource unavailability, and every line here sounds very, naive and simple, but it hides like a lot of problems behind it. Resource unavailability might say that I lost my database again and again and again. I don't have network connection to my RASes, let's say. It means that I need file system to write logs, but I don't have file system because it's not local, right? I need to write to a volume. A lot of things are getting lost all the time, and I need to be able to handle that, right? And not rely on that to continue and working. Running on commodity hardware, again, it's kind of funny, right? Because we know that we have enterprise customers that pay a lot of money for the hardware, but still we need to be able to run on hardware like the computers we have at home. Scaling can be horizontal only. Again, another challenge for enterprise applications that are used to scale up before they scale out, and their scale out is limited, right? Because we never had the need to that. And unattended maintenance. So a lot of things needs to be handled here. Again, to ask how, it's actually the next two sessions, right? It won't cover it completely, but it will cover the external part, like the tools and the architecture and patterns that we can use to apply to that.